In this question, we're told that a car moves from rest, and the graph gives information about the speed, v meters per second, of the car t seconds after it starts to move. And in part A, we need to calculate an estimate of the gradient of the graph at t equals 15. And now to do this, we need to draw a tangent on the graph at the point where t equals 15. And now the reason we need to draw a tangent is because this graph is a curve. We can't find the gradient unless we have a straight line, and so we can use this tangent in order to find the gradient. Now the gradient is a change in y divided by the change in x, and so let's find 2 points on our tangent that allows us to find the gradient. Now that we've found these 2 points, let's use it to find the gradient. The speed at this point is equal to 20, and the speed at the bottom is equal to 16. And then the time at this point is 17.5, and the time on the left-hand side is equal to 12.5. And so the change in y divided by the change in x is equal to 20 minus 16 divided by 17.5 take away 12.5. And putting these numbers into our calculator will leave us with an answer of 0.8. And so using our tangent, we found that an estimate for the gradient of the graph at t equals 15 is equal to 0.8. Now in the second part of part A, we need to describe what our answer to part I represents. Well, now the gradient is equal to the change in y divided by the change in x. We have speed on the y-axis and time on the x-axis. And so we can think of the gradient as the unit on the y-axis divided by the unit on the x-axis. Well, we know that the change in speed divided by the change in time is equal to the acceleration, and so we can say that the gradient of this graph represents the acceleration. Now in part B, we need to work out an estimate for the distance the car travels in the first 20 seconds of its journey, using 4 strips of equal width. Now the distance that the car travels can be found using the area under the graph. Now we want to find the distance in the first 20 seconds of its journey. And now to use 4 strips of equal width, each strip should have a width of 5. Now we can see that each strip is shaped like a trapezium, and although each strip isn't a perfect trapezium, we can use the formula for the area of a trapezium, since we're only finding an estimation for the distance that the car has travelled. We've copied the graph below for reference, and so we can use the formula for the area of a trapezium in order to find the area of each individual strip. Now we know that the area of a trapezium is equal to a plus b over 2 multiplied by the height. And now each strip has a height of 5. Now we need to find the values of a and b for each trapezium. And so we've drawn the lengths of each line on our graph. So we can see that the length of the first line is 4, the length of the second line is 12, the length of the third line is 18, and the length of the fourth line is 20. And so for the first trapezium, the area would be a plus b over 2 multiplied by height, which is 4 plus 0 divided by 2, all multiplied by 5, which will give us an answer of 10. And now the area of the second trapezium would be equal to 12 plus 4, all divided by 2, multiplied by 5, which will leave us with an answer of 40. Now the area of the third trapezium is equal to 18 plus 12 divided by 2, all multiplied by 5, which will leave us with an answer of 75. And finally, the area of the fourth trapezium is equal to 20 plus 18, all divided by 2, multiplied by 5, which will leave us with 95. And so now that we've found the area of each individual trapezium, we can add these all together in order to find an estimate for the distance the car has travelled in the first 20 seconds of its journey. And so the total distance would be equal to 10 plus 40 plus 75 plus 95, which leaves us with an answer of 220 metres. And so we've found that an estimate for the distance that the car has travelled in the first 20 seconds of its journey is equal to 220 metres. Now this question is worth 7 marks, so let's take a look at where each mark is allocated. We get the first mark for drawing a tangent to the curve at t equals 15. We get the second mark for using this tangent in order to find the gradient of the graph. And we get the third mark for finding a gradient of 0.8. We get the fourth mark in part AII for saying that the gradient of the graph represents the acceleration. Then we get the fifth mark for finding the area of each trapezium. We get the sixth mark for adding together all of the areas. and we get the 7th and final mark for getting the correct answer of 220 metres. And so we've now achieved the full 7 marks needed in this question.